Okay, folks, welcome. We'll begin to a thrilling adventure in air pollution land, okay? Now, I should say this lecture is open to only those people who like to breathe. All right? Now, I'm going to tell you a lot of interesting facts here, and one of my pet peeves is air pollution. I kind of like to breathe clean air, and we're going to give you reasons today why we have air pollution. We're going to tell you what it is and interesting facts about it. Now, if you can see this, all this is the information about today, but I want to mention something very bad environmentally happened 5 years ago and 2 days. You know what that was? I'll show you right now. It was the oil spill in the Gulf of Mexico, okay, and it's 5 years, so this is the anniversary of it plus 2 days. Now, this is directly related to what we're talking about because it is the oil industry which is helping to pollute the world's atmosphere and contaminate the ocean and change its wildlife because it's causing acidification. Now, these are just some of the aspects of air pollution. However, most of it boils down to oil, and you're going to see throughout the lecture, or actually later on, I'm going to talk to you about a certain individual who really is in love with the oil companies. Okay. So I think it's coincidence. The oil spill occurred 2 days before Earthday, and it did a good job of screwing up one part of the Earth, which is the Gulf of Mexico. All right, anyway, just thought I'd put this up here, little curtains there. Here is the lecture, and we're going to be talking about it, and I think you will learn a lot today because I'm going to show you some videos, and I'm going to put it bluntly, raise hell about what's going on out there because I tell it the way it is. What I have here is an outline of today's lecture. We got a lot of stuff up there. So this is basically the outline, and I'm going to go into a lot of detail, well, not too much detail, but enough to keep you occupied. Anyway, we're going to talk about the composition of air, air pollution, effects of pollution, the human respiratory system, because we want to know how we breathe, those of us who do it. Color charts about how you recognize different codes depending on the air pollution level, particulate matter, we'll explain all its criteria, primary PM, 2.5, PM10, ozone, sulfur dioxide, nitric oxide, carbon monoxide, air pollution map. This is one of the most interesting things you'll ever find. ZPG and Beijing, what they have in common. Mexico City, Chicago, that's where we are now, more or less, Los Angeles, why we have air pollution and solutions. So we will get going without any further ado. First of all, let's see what we are all breathing. This is a chart of approximately what's in the air in an unpolluted atmosphere. Now, normally the books will say the first four, because that's basically what we're interested in. Now, the composition, probably in this room, certainly not in Beijing or Mexico City or Houston, or LA for that matter, but for the most part, most of an unpolluted atmosphere contains 78.09% nitrogen, 20.94% oxygen. Argon, which is an inert gas, is 0.93. And by the way, I should point out, easy way to remember argon, when we are no longer in this room, we are gone from here. Just thought I'd mention it, easy way to remember. And then, of course, we have the bad one, carbon dioxide. Now notice, this has hit a record number, 0.04. Well, at the time of the Industrial Revolution, it was 0.027. Now you might say, well, it only went up a little bit. Yes, but that little bit is enough to cause the problems we see today. We all see global warming, climate change, forest fires, droughts, as we see in California, and it's just going on and on. We're also changing the ecosystem of the ocean. We're changing the oceans because we're acidifying it thanks to carbon dioxide. And I'll explain how that happens. It's real easy. There is an acid called carbonic acid. When you mix water and carbon dioxide, you're getting carbonic acid. Carbonic acid is a mild acid, but nevertheless, it's still acidic. And when you mix water with carbon dioxide, you get carbonic acid. And for that reason, too, in the bloodstream, those of us that have blood, the carbon dioxide is greater in the veins. The reason, so you have a lower pH. It's more acidic in the veins than the arteries. The arteries have more oxygen, therefore less carbon dioxide, and since a lot of the blood is water, you have less carbonic acid in the arterial system than the veins, so that's why it's more basic. So the veins are more acidic, similar to the ocean, because we're adding more carbon dioxide. So these are the four major components of an unpolluted atmosphere. And I want to point out, too, that everything below oxygen, all these other gases, make up less than 1% of the normal environment. Argon is less than 1%, and then carbon dioxide is way less, and then all these others in order of decreasing amounts. We even have sulfur dioxide there, but it's such a small amount you don't notice it. But this is approximately the amounts, and this is the parts per million, and we're going to be talking about parts per million later on today too, when I go into the details of some of the components that we do not want. So what's happening here, I want to point out something, which I don't think most people realize. As the CO2 concentration increases, notice I wrote and rising, the others are going to go down slightly. Not a lot, but as this goes up, everything else goes down. That's just common sense, right? Because you can have 100%, right? If you add more of something, you're going to have less of something else. So this is the number scheme of, or the composition of unpolluted air. Now, here's another way of looking at it, a pie chart. And if we notice, nitrogen makes up most of the pie chart, and then we have oxygen and everything, carbon dioxide and argon, and then all the other gases make up the rest. So as you can see, nitrogen is very important, but as you all can imagine, nitrogen is inert. That means it doesn't react, and that's actually good. But anyway, I want to point out something too, that you do not want too much oxygen on the planet. I think the maximum that the planet can hold is about 25%, because once you go more than that, you're in danger of explosions and things like this, and it makes everything dry. So we don't want that. And then the minimum amount for humans to breathe is about 19.5%. Okay, so we don't have much of a leeway there. All right, now here's a good family, unpolluted area. How would you like to come home every night like that? But as you're going to see, we all know what China looks like now. You ever see Beijing, the streets of Beijing? The people are wearing masks. Now, I have something so incredible to tell you about Beijing. I'll tell you that later on, that only I would come up with that, but if you look at it, you'll find it to be true. But anyway, they're wearing gas masks. It's kind of hard to eat with your mask on. Not to mention the salad and stuff is going to be contaminated, but hey, I guess you can say a little air pollution adds flavor. As a matter of fact, that reminded me of a story once. I was here in this here restaurant, and the waitress said, "Do you want some wine?" I said, "Sure." And so she gave me the wine. I took a sip. I say, "Hey, is this wine from California?" She says, "Yeah." "How do you know?" I say, "It's simple. You can taste the air pollution." All right, anyway. So, now, let's look at the causes of air pollution, of which I'm going to give you the 4 or 5 major ones. Burning fossil fuels, okay? This is the biggest thing I have. I despise fossil fuels, which include oil, coal, and gas. And let me just say one thing. The only good use of oil, as far as I'm concerned, is for lubrication and making furniture. And what do I mean by furniture? Well, if you look around this room, you have furniture will include also the speakers, tables, drawers. You know, you can get a lot of equipment made out of plastic, okay? Even this case, or the keyboard for the computers, or the cases for computers. Many of them are plastic. So instead of using wood to make cabinets and stuff, you can use it for furniture. And of course, lubrication. And if you look around, every chair here is not made out of wood, it's made out of plastic and metal, which is good for the wood industry, that we don't cut down the trees. But that's the only case for wood, for oil. You know, lubrication, of course. But of course, we use it for energy, which is bad. Anyway, we also have agriculture. We're going to ask, how does agriculture contribute to air pollution? Unfortunately, it contributes a lot, especially with pesticides. And what they do is, pesticides they spray, and a lot of it winds up in places where it shouldn't be, okay? It goes into the atmosphere. Plus, with agriculture, we add a lot of nitrogen. We add a lot of nitrogen fertilizers, and of course, some of that nitrogen fertilizers winds up in the atmosphere, and that causes nitrogen problems. And we have that too. And then we have exhaust from factories and industries. This is obvious. We have thousands of factories, or hundreds of thousands all over the world, and they're spewing out waste, and unfortunately that waste is a lot of pollution, winds up in the atmosphere, and this includes, of course, electric generation, okay? And we're going to find out that there is only one safe way to generate electricity, and I'll cover that later. And all this refers to, will help cut down pollution. Then we have mining operations. I don't know if you've seen mines, but they do a lot of damage both to the water and the atmosphere, okay? If you've ever seen the way they do mountain mining, you know, they're destroying mountains to get the coal. And as a matter of fact, there's a movie called The Last Mountain, and Bobby Kennedy Jr. wrote about it, and they made a movie called The Last Mountain, and it's about the destroying of the mountains in Appalachia just to get the coal, and they see all the damage. And if you see that movie, which you can get for free on the internet, you'll see people's lungs are becoming contaminated. He takes a rag and cleans the house, the outside, and you see all the coal dust on it. Not even the mine, it's just the coal dust blows with the wind, and of course the wind is carrying it to other places. So whenever they blow up mountains, you get a lot of particles which are blowing all over the place, and not to mention the people's lungs. Then, of course, we have indoor air pollution. Now, notice I mentioned here the American Academy of Environmental Medicine. Well, this is the organization I belong to since 1989, and they deal with problems such as indoor air pollution, or people who get exposed to various substances and it makes them sick. With indoor air pollution, sometimes is worse than outdoor air pollution, and that's because of the situation where they have carpets such as this. I don't know if this is a good carpet, it's probably not, because it's not made out of wool, but it gases off when it was brand new. It gases off some of the chemicals in it, you know, to keep the color, to keep it looking the way it is, and these are real problems. And many of these people who see the doctors, they have these problems. And I want to point out that the doctors who work at the American Academy of Environmental Medicine, I mean, they're all over the U.S. We call them clinical ecologists. So these are the ones that deal with these so-called environmental problems that people have. Now, as for the effects of air pollution, it's obvious. You get respiratory and heart problems. As I mentioned too, if we put out too much carbon dioxide, we get acid rain, we get depletion of the ozone layer. When we spew out the chlorofluorocarbons from car air conditioners and other air conditioners, but the cars are the major culprits. And of course, we don't want ozone being destroyed because that protects us from ultraviolet light. And then, of course, as I mentioned earlier, we have, well, it's going to affect the oceans, and of course we have sea level rise, melting icebergs, etc. And this causes a lot of problems, especially those people who depend on the snow on the tops of mountains, because there are many countries that have people living at the bottom of the mountains, and they depend the ice melt, the water. That's where they get their water from, the ice melt, and that causes a problem. Because they're going to run out of water. Can you imagine getting up one day trying to turn on the sink and you have no water? Well, that's what they're going through now, because the ice caps are melting on the tops. And then we have eutrophication. I'm sure nobody knows what eutrophication is. Is there anybody in this room who knows what eutrophication is? He knows because he teaches environmental science. There's my good friend Pete. Yeah, eutrophication is the over-nutrification of a body of water, especially a lake. And what happens is you add too many nutrients. And when you add all those nutrients, a lake will eventually turn into dry land. Because what happens is the nutrients feed the lake, then you have algae growing. And when you have so much algae, they're going to decompose, deplete the oxygen, and then they're going to, as they decompose, they're not going to decompose totally, they're going to settle down to the bottom. Eventually, it's going to turn into dry land. And this is a problem. And one of the problems is the nitrogen that we're releasing because of agriculture. And nitrogen is a limiting factor in plants, which means it's very important for plant growth. And so if you have less nitrogen, you have less plant growth. And that's, of course, why the farmers put it on their land. And then, of course, effect on wildlife. I think many of you forget, too, that animals and other organisms have to breathe as well, okay? So it's obvious that they're not going to do too well. Now, what I have here is the human respiratory system. I just want to tell you what it's about just for a minute. I'll go into it real quick because this is very important. And it doesn't take too much brain power to realize that you know, it's a very delicate system, and if we mess it up with things we don't want, we are going to be messed up. So I'll just mention what I do in my classes. I explain to you how we breathe and how substances go in. First we have our nose, then we have our pharynx, which is the throat area, then we have the larynx, which is the voice box. And of course, that's why you see a lot of smokers, they have to have a laryngectomy because the smoke messes that up. It gives them a disease, but like cancer or something, and that's of course bad. But you know, the air goes through the voice box, then it goes down to the trachea, then it hits the bronchus. You have two, they break off like a river. Think of this as a river, and then you have branches, and then the bronchus breaks off into bronchioles, and then here we see a bronchiole that breaks off into the air sacs, okay? And this is where the air pollution gets quite dangerous, that I'm going to talk to you about in a few minutes, okay? Because these air sacs are going to get clogged up with little particles, and I'll even tell you what the particles are, and we'll talk about that. Now, before I do that though, I want to show you this color chart because this depends on how many particles you have per cubic meter. Now, just like everything good is green, moderate is somewhat acceptable. Orange is not too acceptable. Unhealthy, that's bad. Very unhealthy, that's even worse. Hazardous is even worse than that. And what you're going to see today, a special map of the world as we speak. With all this technology, we can see how bad certain areas of the world are, and I'll cover that in a few minutes. You're actually going to see color-coded areas with numbers on them throughout the world. I have a special map that they update all the time regarding pollution, which I think is clever. Now, I want to talk to you about particulate matter, first of all, because this is what we get into the lungs. Now, we call it PM. PM stands for particulate matter. After that number, you're going to see either 2.5 or 10. What does that 2.5 or 10 mean? That means that that's either 2.5 micrometers or 10 micrometers. How big is a micrometer? Well, there are 1 million micrometers in a meter, okay? And it is these small particles which will lodge inside the alveoli here, and that can cause serious problems, okay, with breathing and respiratory problems and everything else. So we use the word micrometer. The old term was micron. Now, you probably will hear the term micron, but they don't use that anymore. Some people use it. You may find it in books, but the right word now is micrometer. And again, this is a metric system. And there are 1 million of them per meter, okay? For those of you not familiar with the word meter, easy way to remember. Hey, Joe, I know this girl. I want you to meet her. All right. Now, here we see particulate matter in relation to a hair, okay? That is a human hair. And this is the way they measure air pollution, and that's what those numbers mean. I'll explain that to you, that color code. Anyway, what we have here is particulate matter, is an air pollution term for a mixture of solid particles and liquid droplets found in the air, okay? The pollutant comes in a variety of sizes, and it comes from chemicals and other things. Also, coal dust. Particles that are small enough to be inhaled have the potential to cause health effects, okay? Of particular concern is particulate matter 2.5, which again means 2.5 micrometers, okay? And that can go deep into the lungs. And here we see some pictures. Here we see an actual hair, okay? And for those of you who've seen hair under a microscope, you'll see it has layers like this. You need a good scope. You can actually see it with the light microscope. you can make out the way the hair grows, something like this, okay? And then a hair is about 50 to 70 micrometers in diameter, so that tells you approximately what it looks like. Here we see 2.5. PM 2.5 is combustion process, combustion particles, organic compounds, metals, etc. And here you see what sand looks like, small sand, 90 micrometers, okay, in diameter. So this gives you some idea in relation to a hair. So a lot of these are a lot smaller. And you know, a hair really looks pretty big, but just think it's still relatively small in one way, and yet micrometers are a lot small, the particles. 2.5 is about 1/20th to 30th of a hair, so they're easy to get into your lungs. And of course, PM, particulate matter, comes from forest fires, wind erosion of the soil, and human activities, such as we're spewing out. I'm sure everybody has seen a diesel truck, right? Or even the diesel trains, all that black smoke is coming out, and it's really a lot of particles, okay? And of course, we have car emissions, smokestacks, constructions, all that stuff. Okay, now, what we have done, what the scientists have done, they have put in some criteria pollutants. These are the major ones that they're mainly concerned with. Of course, you have other pollutants too, but these are the major ones that clog up the cities, okay? And it's obvious why. And I'm going to go over these, and I'm going to give you some numbers of these, and I'll tell you why I'm going to give you those in a moment. Anyway, we're dealing mainly with particulates and lead. Lead used to be a concern, but it's not a concern as much now for the simple reason lead used to be in gasoline, and they got rid of leaded gasoline because they found out, of course, it's no good, especially for children. And when children play around parks and playgrounds, there's usually a lot of car traffic. And in the olden days, the lead would come out of the exhaust, and the kids, of course, being young, they put a lot of stuff in their mouths and things like this, so the lead will make them sick. And of course, the purpose of the lead in gasoline is to get out the knock. You know, they used to go pinging. I'm sure many of the older cars used to do it, but the newer ones don't. And it was the lead in the gasoline that prevented the pinging, or the so-called knocking. And of course, I haven't heard knocking now for a long time, so evidently they made the engines better, and the gasoline is probably better, so they don't have to ping. So lead is still a problem, though, in some cases, because let me tell you this, as many of you know, not everybody, but many of you know, I also work with asbestos during the summer and Christmas time. I'm in charge of the removal projects, and those people who work with asbestos also get rid of lead in homes and things like this. There's lead in many places, and they have to get rid of it, so they have to wear the same type of protection. And, you know, it's a hassle to get rid of lead because they realize that that's a problem, especially in lead paint. They want to get rid of it. Okay, then we have carbon noxes. We call noxes are oxides of nitrogen, and we use the general term noxes, okay? And it sounds a pretty good way to remember because you all heard the term obnoxious. It has the word nox in it. That's pretty cool, isn't it? I just thought of it, but it's true. Anyway, so they generate three gases which are not too good for you. Nitrous oxide, well, used to hear about that, it's laughing gas, okay? Nitric oxide and nitrogen dioxide, okay? This is probably the worst one, nitrogen dioxide for you, and that, of course, is pretty bad. Anyway, so they measure the nitrogen oxides in the environment. Then, of course, we have carbon monoxide. That you do not want too much of because I'm going to go into the health effects of that. That's obviously no good. You have more than 5%, and that's enough to kill you because it takes the place of the oxygen in the blood. Actually, the blood prefers carbon monoxide to oxygen. If you knew that, it has like an affinity of 300 times more. It prefers carbon monoxide, interesting. And then you would think it prefers oxygen, but the carbon monoxide, right, stays to it more than the oxygen. Interesting. Then we have volatile organic chemicals, and these are called VOCs. And what that means is volatile means evaporate. That's why I think they started in Los Angeles. When you fill up your car, you have a little cover. You know, you put the hose into the hole where you put the gas, and there's a cover there, so the fumes will not come out. And then, of course, we have sulfur dioxide. That is found in cheap oil and gas because it's a contaminant of coal, oil, and gas. And of course, when you burn it, when you burn cheap oil to make energy or something, or cheap sulfur, which is unfortunately coal. Coal has a lot of sulfur in it, and when you burn it, you get sulfur dioxide, and of course, that's bad. And then, of course, we have ozone. Now, most of you heard of the ozone, which is in the stratosphere, which is the level above the troposphere, the part we are in. But we also have ground level ozone, and that is bad. The good ozone up in the stratosphere protects us against UV light, ultraviolet light, which of course is very bad for the skin and causes cancer and things like that. But ground level ozone is produced on hot sunny days, especially where you have a lot of traffic. And the ground level ozone is made when we have a lot of NOxes present, nitrogen oxides, okay? And I'm not going to go into the chemistry here of it, but I just want to point out that whenever, internal combustion engines, they produce a lot of nitrogen oxides. And the reason for that is because in order to get a combustion engine, you got to have 15 parts air and 1 part gasoline. And of course, the majority of the air is nitrogen. Therefore, inside the internal combustion engine, you get the reaction and you're producing the NOxes. And that in turn is going to mix with the ultraviolet light, and you're going to get ground level ozone, okay? And that becomes an irritant, especially in areas like Los Angeles where it's hot and sunny during the daytime. And of course, the sun acts as a good energy source. And we'll discuss this. Now, what I've done, this comes from a book. This puts all the criteria, air pollutants, in a good way to look at them. And if you look closely, you will see that the majority of these components, criteria pollutants, come from transportation. See it? If you take a look here, you have transportation for particulates, lead, especially the trucks, nitrogen oxide, transportation, with carbon monoxide. Most of the carbon monoxide comes from transportation. Part of it comes from the VOCs, transportation, and of course sulfur dioxide is mainly in power plants and things like this where they burn coal and oil to generate electricity. Okay? Now, I also want to point out the differences between primary and secondary pollutants. And the primary pollutant, by the way, comes directly out of the smokestack. A secondary pollutant is a result of a reaction with primary pollutants. A very good example is some factories produce sulfur dioxide coming out of the stack, and when that mixes with water, you get sulfuric acid. And I'm sure you know what sulfuric acid does. It corrodes things, and of course it's no good for you either. Now, what I want to do is, I want to go into these categories now about PM 2.5, PM 10, sulfur dioxide, carbon monoxide, and the NOxes. And I'm going to go into more detail because these are very important now. And I have lots of stuff for you here, especially movies and stuff that I'll play a few minutes later on, which I'm sure will shock you. Anyway, here we have PM 2.5. You get lung function, asthma, chronic bronchitis, cardiovascular system, premature death, affects children and the elderly. And again, it's caused by combustion. Crustal dust comes from the earth, and diseases and mortality. So this is real stuff that you got to be aware of, okay? This is important stuff here, okay? And I don't have to read everything to you, but you get the general idea. Now, I have here a bunch of charts, which I got from my cell phone. Why would I get this from my cell phone? Because, folks, believe it or not, I have an app on my cell phone that gives you the concentration of pollution in China. That's right. It's a free app, and it tells you about the pollution in China. Now, why am I concerned about China? Well, first of all, it's interesting. They have an app for it. It's free, and they give you the guidelines. And so I'm going to go over all these with you just real quick. I just want to point out just a few things. Obvious, I'm not going to spend time going over the numbers in detail. I just want to point out. Now, on the phone, they give you these guidelines. And The MEP in China is similar to our EPA. That stands for the Ministry of Environmental Protection, okay? That's the equivalent of our EPA. And what they have done, they have divided up the categories. Notice that the Chinese categories are excellent, good, lightly polluted, moderately polluted, heavily polluted, severely polluted, and beyond the index. If you're beyond the index, which many of the days are, well, it's probably not a good day to breathe. You wouldn't even bother getting up in the morning. Of course, the U.S. EPA is good, moderate, etc. Now, notice, this stands for micrograms per cubic meter. Since we don't know exactly how much we're getting, we know the concentration in the air. Obviously, if you have good under 35, that means you're pretty healthy, okay? And this is micrograms per liter. If you go above 500, you might as well say, that's all, folks. Okay. Over here, we have micrograms per meter in the U.S. Notice the numbers are different. Why do they have different numbers? I have no idea. That's the way they do it. Notice, too, though, hazardous here, still, they give you the 500 mark, except here it's almost the same. They just use these categories. We use these. Now, talk about PM10. Again, particulate matter, 10 micrometers. This comes from natural sources such as volcanoes, storms, forests, and grasslands, and ocean springs. Now, I want to point out that nature also produces air pollutants, but of course we, humans, are doing a lot more. And by the way, the term for when humans produce something, we use the term anthropogenic. Those of you who studied anthropology, well, anthro means man, so study of man, anthropology, anthropogenic. We use the word genic from the Bible. Genesis means it's being formed by human beings. And of course, only humans burn fossil fuels, make power plants, and does industry. With nature, of course, you have forest fires, vegetation, sea spray. Now, my main field, by the way, is oceanography, and I love the ocean. I love the smell of the ocean, and you know, it's nice when you're on the beach to get sprayed, but of course, I'd rather get sprayed with water instead of air pollution from a nearby electricity generating plant running on coal. Anyway, the health effects are similar to those with the PM 2.5, same stuff, and of course, it's obvious. If you're not breathing clean air, it can't be good for you. Now, here we see the PM guidelines, same thing. They go on micrograms per cubic meter. I should have put the cube up there. That was an error. Anyway, that means cubic meter. You know, a meter this way, and this way. And again, they go up to about 600. Again, this way above 600, above the index. Then we have ground level ozone. What does that do? As I mentioned, that's caused by too much nitrogen, caused by cars, the internal combustion engine. And anyway, again, lung function, lung diseases. This is a very big concern in Europe, okay, because they have sort of warmer weather than we do, and they have too many cars. It doesn't matter if their cars do better on gas than we do, they just have too many of them, right? Too many is still too many, whether they're small or big, it doesn't matter. And now, in Europe, they showed that for every increase of 10 micrograms per meter, daily mortality rises by 0.03%. Okay. Now, let's look at the Chinese Ministry of Environmental Protection ozone guidelines, and notice they use different amounts. Here, this is again microgram per cubic meter, and it goes from excellent all the way down to severely polluted above 800. We, in the U.S., we use parts per million, and what a part per million is, that means if you have, let's say, 1 million liters of air, and you have 1 liter of a substance, that's what it means, okay? Just put, you have 1 million, and then you put in 1, that's what 1 ppm, okay? So here, with ozone, obviously you don't need that much. Again, this is micrograms per cubic meter, parts per million. And again, since we're dealing with concentrations, you don't know exactly how much you're getting, so they could just say the concentration of the atmosphere that you are in. Then we have sulfur dioxide, and this is used for, you get this from burning fossil fuels for heating and power generation. And again, look at this. They all have basically the same effects on the human respiratory system. And we're going to see what happens when you mix them together. Okay, and I'll explain that in a few minutes. You get something called synergism. Synergism is when you add two chemicals. The combined effect is actually a lot worse than each one taken individually. And by the way, hospital admissions increase when you have high sulfur dioxide. And remember, these are the criteria pollutants. They're basically used all over the world. Here again, we use the SO2 guidelines in China. They use a little different numbers than we do. China, they use micrograms per cubic meter. Here we use 8-hour parts per million, the US EPA guidelines. Then we have nitrogen oxides, NOxes. They come from heating and power generation in ships. The vehicle, the symptoms, again, bronchitis, reduced lung function. Virtually everything's the same. You get inflammation of the airways, though, when concentrations exceed 200 micrograms per cubic meter. And by the way, nitrogen dioxide is the main source of nitrate aerosols in the presence of UV light and ground level ozone. And just to tell you how the ground level ozone is produced, the formula for ozone is O3, which means every molecule has 3 atoms of oxygen. But what happens here is the UV light breaks apart the NO2 to give you nitric oxide, and then you have 1 oxygen left. That oxygen is going to combine with the atmospheric oxygen, which is O2, to give you O3, and that will give you ground level ozone. Relatively simple chemistry. Anyway, I'm big on chemistry, but that's essentially what happens. So that is why when you have a lot of cars, you have a lot of nitrogen dioxide being produced. One of the oxygen is going to be released from here because of the light. Generally, you know, sunlight has UV light. I mean, the ozone protects us, but it doesn't protect us 100%. So you get a little bit, and then you're going to have some oxygen lying around. That's going to mix with the O2 to give you O3, and you wind up with a lot of ground level ozone. Then again, we have the NO2 guidelines from China and the US. And again, notice this, when you have too many cars, you have above this 2340 micrograms per meter, and again, we use parts per billion. Now, I want to point out something to you that I do not think any of you heard of. In the year 2010, China, guess what? They had a 100-kilometer traffic jam. Lasted for 10 days. I don't know if any of you heard of it. You ever hear of it, Pete? Yeah. They had a 10-day traffic jam. So you think these traffic jams, can you imagine 10 days, 110 kilometers? I mean, you're talking about almost 60 miles or something like that. Traffic jam. So it actually happened. I wondered, I'm sure they didn't leave their engines on for 10 days. Anyway, you could look it up on the internet. You can see pictures of the traffic jam. It used to be in China, I think in the 60s and 70s, there was 1 car for every 220,000 people. And here at that time, we used to have 1 for every 11 people here in America, but now I think we have 1 car for every 1.5 people in America, and in China now it's about 10 or 11, something like that. So the number of cars has increased along with the Chinese population, and that of course is very bad since they use gasoline. If they use solar power, which they don't exist yet, I don't think we'd have much to worry about. Anyway, now let's go into the this one, carbon monoxide, one of the other criteria pollutants. How do we get that? Well, first let's look where that comes from. You get carbon monoxide from the partial oxidation of carbon-containing compounds. Let me give you a good example. If any of you have ever been in a room with a lot of smokers, that's really bad. The carbon monoxide is pretty high, okay? I myself do not like cigarettes. And as a matter of fact, interesting story about that. I once had a friend of mine, he says, Dave, can you give me a ride in my car? I drive an Echo. By the way, I drive 2 things. I drive an Echo and I drive my students crazy. But that's another story. Right. So he said, Dave, give me a ride. I say, sure. He says, Dave, do you mind if I smoke? I say, why? Are you on fire? Okay. Anyway. So anyway, okay. So anyway, so you get carbon monoxide from incomplete combustion, all right? And also you get it from not having enough oxygen to produce CO2. And then, of course, we get it from forest fires, okay? Pretty interesting. and we get it from volcanoes a little bit up there. That's why I put a volcano up there. It's not doing anything now, but it will. And of course, we have forest fires. Now, what makes this so bad is the fact that now, if you notice in California, the forest fire season in California used to be only less than 6 months out of the year. Now it's all year round. Why? Because of the drought, mainly contributed by global warming. You see that? So global warming has increased the forest fires, and we call something like that a threat magnifier, which is one of the effects of what global warming does. It makes a bad situation worse, and as you know now, Jerry Brown, the governor of California, he signed a law that they're trying to use less water, okay, because we have a serious problem with the water problem, and it's just making things worse, and now you have more potential for forest fires, which actually do come. All right. I want to point out, too, that worldwide, the largest source of CO, or carbon monoxide, is in the troposphere. That is the area where we are right now. And you produce 5 times 10 to the 12 kilograms per year, which is many, many tons, to put it bluntly. A kilogram, by the way, is equal to 1,000 grams. So 1,000 kilograms is equal to 1 metric ton. So we're producing out a lot of metric tons. Just to show you the difference between a metric ton and the short ton, which are the ones we use. A short ton is 2,000 pounds, a metric ton is 2,200 pounds, okay? So it's 22 pounds, 2,200 pounds is a metric ton, so roughly a metric ton is 10% more than the short ton, okay? When we deal with kilograms, it's the metric system. All right, health effects of CO2. Usual. You can see some of the effects. However, one thing is that it combines with hemoglobin to produce carboxyhemoglobin, which I mentioned before. It takes the space of the hemoglobin that should carry oxygen, but the blood prefers the carbon monoxide, which you might think is strange, but nevertheless, that's the way it happens. And it may lead to seizures, coma, and death. So carboxyhemoglobin is again the protein in the blood which grabs the oxygen, but in this case it's going to grab the carbon monoxide, and of course that is very bad. And again, these are other symptoms, your headache, nausea, vomiting, dizziness, weakness, heart damage, etc. And again, we have the guidelines for that. Again, the Chinese, the MEP, we use micrograms per cubic meter. For the US, we use ppm. And again, we have to convert these, but those are the systems. The difference when you convert it is not going to, it's going to be a little similar, not exactly. All right, now what I want to do is show you something. Remember I just showed you the numbers, okay? So what I have here, everything prepared here, I want to show you this map. If you look at this map, notice what we see here. We see numbers. Now, notice the color codes. You remember the color code, right? Let me see if I can blow this up. Hey, I think if I did this, zoom in a little bit. Let's go. See it? Okay. Isn't that interesting? You see the numbers there? You also see the colors. Now, notice, which continent do you think is the most polluted? Well, it's Asia. See it? Now watch what we're going to do. I just want to show you this map. I'm going to spend some time on this because this is interesting. Here, we're going up here and we zoom in. Isn't that great? Notice this whole area. Guess what country this is, folks? A little bit of China. Notice, there's not much green or yellow there, is there? So what does that tell you? It's very bad. This is the way it is now, as we speak. See? Real-time map. Isn't this a great map? Now, I want to spend a few minutes on this to show you something. We can pick any number. However, notice the higher the number, the darker the color. So, 365. Let's see what that says. It says here, Economic Development Zone, and this is in China. Let's go up closer. What's that say? Very unhealthy. See it? So these people here, as we speak right now, they're not breathing good air. But take a look. Almost all of this whole area is bad. you hardly see any green. Where do you see the green or yellow, which is either excellent or good? By the way, the green is excellent, the yellow is good. If you look closely, they're all red. Let's take this one, wherever that is. Where is that? Unhealthy. Let's see what city that is. Well, it doesn't say. Let's take another one. Let's take this one. Holy mackerel. You ready for this one? 840. Wow. And notice that 50, anything between 0 and 50 is excellent. How many times is that? That's quite a few times. That's like 16 times, almost 17 times the good value. Isn't that amazing? You see? Dangerous. I wouldn't want to be there. In fact, I wouldn't want to be anywhere here. Why is that? Well, obviously, you know, labor is cheap and they don't want to invest in pollution controls. Let's see what a good one looks like. Let's go up here and see where this one is. That one is, let's see, let's say where that is. Let's take one down here. Let's take this one. This is an excellent one. That's a good one. See it? This is the U.S. consul over here. I'm not sure if that's Sri Lanka or somewhere down here. That's in India. Let's take this one. India. That would be, that's the Hyderabad. Unhealthy, 160. You see it? This is really a great map. So you can look at any one time. We're going over to the U.S. in a minute. I just want to show you, let's see if we can get, let's look at India here. India doesn't have that many big cities, although Mumbai, which is used to be called Bombay, is actually more polluted than Beijing, they say. Now let's look at Europe. Look at that. What does that tell you about Europe? Notice, you have green and yellow. Remember, yellow is good, green is excellent. Anything up to 100 is between 50 and 100, see? So Europe is not so bad. There's only, at the present time, as we speak, we have this one in Europe. Let's see where that is. Let's see if I can get it. I'm not able to get it down here. I can't tell. You gotta get rid of this here. But anyway, that 151, I don't know where it is. Evidently, that's no good. Let's take 117, which is somewhat unhealthy. Yeah, I don't see the city it's in. But anyway, was that where we see it?
Just take a hover over the color.
Oh, right. Yeah, that's Croatia. Yeah. Oh, that one? Oh no, this one. Yeah.
I saw Croatia.
No, I don't think so. Anyway, let's see what this one is. Should we get that? Oh, Turkey. Okay. But now, if you notice, let's take all of Africa. Notice Africa is not even up there. Why? Because Africa is the least polluted of all the continents. They're also the least amount of people per cubic mile, per square mile. Okay. Africa is actually the least densely populated of all the continents, of course, except for the Antarctic and Arctic. Isn't that cool? Bet you wouldn't think that. There's not much industry in Africa, okay? And the biggest place here we see is South Africa. Let's see what they have. Good, see? It would be nice if the whole world were good, wouldn't it? Remember, the numbers, see, this tells you. By the way, AQI stands for Air Quality Index. You see it? Air Quality Index. So, pretty interesting chart. Look at that. Asia is almost entirely messed up. Let's see what this 117 is. Oh, that's in Japan. Yeah, it says NODA, Japan. So, interesting. Let's go over to the U.S. Notice, thanks to the U.S., get a load of that, folks. Not bad, huh? I don't see one red spot there, do we? However, where do you think 154 is? I'm not sure if that's Mexico City. I don't think it is. Isn't that cool? It's a great map. Where is this? Mexico. It's not Mexico. Santa Fe, Mexico. Let's see what's there. Yeah, what's that? That's, what do you mean, 353? The number? Oh, this one. Yeah, that's bad. That's purple. Yeah, that's El Salvador. Oh, San Salvador. Now, I don't know why it's written in Chinese, but evidently this could come from China too. I don't know. But anyway, so that's bad. Look at that number, 353. Now, let me do this. Let's go back to my chart for a minute here. Let's go back up here. I want to show you the color scheme again. Let me just throw the zoom right back up here. It's quick to do it this way. Look at that, see? So remember, this shows you the numbers. You see that? The color code? So you're here between 301 and 500. I mean, that's bad. But what I'm impressed about with this chart is the U.S. So you can thank the EPA that we have it, you see? And there's nothing here that's above yellow, which I think is cool. Look, Illinois, it's all green, see it? I think that's amazing. Let's see what else we have. Australia, I don't think. South America, although one of the most polluted cities in the world used to be in Cubateo, Brazil. And they've since cleaned that up. Let's see in Australia. I don't think there's much in Australia. There it is. Not much there either, see? Because most of Australia is desert. See that? By the way, do you know why you can't starve in the desert? Because of all the sand which is there. Baloney. All right. So anyway, so we see this chart here, and so we're in pretty good shape. Even Mexico City, let's see, it should be around there. Let's see what that one is. Oh, that's Jalisco. Yellow, not bad, moderate. Okay. So it's good to see a lot of green. This is the one area where we should see green. Anyway, okay, let's continue where we left off. Now comes the good part, folks. Well, let me just show you a little bit about India, and then the good stuff's coming right now. Okay, let's talk about Mumbai. Well, I just so happened I looked up air pollution in India, and there's even a Wikipedia page on there, air pollution in India. Now, according to the news, I just picked up some information 2 weeks ago. Mumbai, which used to be called Bombay, is actually more polluted than Beijing. But I don't have many pictures of Mumbai, but I do have some of Beijing, which I will show you in a few moments. So, India, they have a lot of congestion, they drive small cars, but again, I want to point out the fact that it doesn't matter the size of the car. If you have too many of them, you still have too many. Each one is spewing out carbon monoxide, carbon dioxide, and a lot of other garbage, okay? So it's typical. This is what happens when a country becomes affluent. When one used to be poor, and then you become affluent, it's not necessarily so good to be affluent, okay? If you like to breathe, it's not a good idea. All right, anyway, so much for that. I think you get the point. Okay, now comes the good part, the moment we've all been waiting for. Okay, this is something that really intrigued me, and again, I'm probably one of the few people that noticed this. Okay, I want to show you what this means. I'm a science fiction fan. In 1972, that was, based on my calculations, unless global warming messed up the numbering system, 43 years ago, right? 1972, is that correct? Now, ZPG was the name of a movie about population control. It stood for Zero Population Growth. And I'm going to show you the first 2 minutes of the movie because it deals with two issues: air pollution and the Earth's being problem. You're going to say, well, what the hell is a being problem? Human being problem. Okay. Now, I know that's what it deals with. Hey, Bruce. Okay. Notice the air pollution. Now, I'm going to show you the movie in a moment. Look at Beijing, 2013. How many years ago was that? That was only 2 years ago, but that was like 41 years after this. If you notice, which looks more polluted? The one in the movie or the way it is sort of today? You see that? Isn't that amazing? So what have we learned, us, the human race? Absolutely nothing. We knew as far back as 1972, first of all, we have a population problem, we have an air pollution problem. You see it? But I would say this picture is actually worse than that. I'm sure you would all agree. At least here you see some clarity. So, and by the way, all this is supposed to be pollution, okay, in the movie. So what I have done, I'm going to show you the beginning of the movie, Zero Population Growth. And you beat it, get out here. Okay, I got everything set up, but it's going. It has sound.
announcement from the President of the Society. This announcement will bring you the result of the deliberations of the World Federation.
They're all wearing gas masks.
Attention, all citizens.
How much time do I have?
6 seconds, sir.
5. My fellow citizens.
2. What?
My fellow citizens. It is with a heavy heart that I bring you the findings of the Council. After deliberating in continuous session for the last 4 months in unceasing efforts to find a solution to the devastating problem of overpopulation threatening to destroy what remains of our planet, the World Federation Council has considered and rejected all halfway measures advanced by the various regional scientific congresses. We have also rejected proposals for selective euthanasia and mass sterilization. Knowing the sacrifices that our decision will entail, the World Council has nevertheless reached a unanimous decision. I quote, "Because it has been agreed by the nations of the world that the Earth can no longer sustain a continuously increasing population, as of today, the 1st of January, we join with all other nations of the world in the following edict. Childbearing is herewith forbidden. Child shall be the gravest of crimes, punishable by death. Women now pregnant will report to local hospitals for registration. I earnestly request your cooperation in this matter."
Obviously, we're not too happy with that. So anyway, you get the idea. Now, could this actually happen? Maybe. Now, the point I'm trying to make here, did you see the air there? They're all wearing gas masks. Now, if you see the movie, by the way, you can get it for free. Just stick in zero population growth, put it in Google, and get it. It's all free. The masks are not really good masks. All they did was cover the face, you know. They didn't look like much, but of course it's a movie. So anyway, isn't that incredible? Have any of you heard of this movie? Well, you have now, and you'll find it interesting, and I'll just tell you what it's about real briefly. Oliver Reed and Geraldine Chaplin, I think the daughter of Charlie, anyway, they're a husband and wife, and she gets pregnant. Now, in the houses of everybody, there is an abortion machine, okay, that aborts the woman, you know, shines a light, and she decides not to go through with it, and of course they have a baby, and then, you know, that's, the movie goes on, and then they figure out a way to not get killed. And anyway, I won't tell you any more. But anyway, it's one of those movies you might like if you're into that sort of stuff. Anyway, for that time period, it was pretty good, I guess, at the time. Remember, that was 42 years ago, and we still have today a population problem and the air pollution problem. So, you know, it's funny how these movies come out, and we realized years ago that we have these problems, okay? Now, what I want to do, let's go to Beijing at the moment. Now, I have this set up. I don't know, has anyone here ever been to Beijing lately? No, well, okay, let's see what we got. I think that's it. Now, this is a video of Beijing. And we're going to check this one out and see how this one. Let me see if this one. Look at this. That's Beijing recently. Nice and clear, isn't it? This is just recent, you see? This is no joke, so this stuff really happens, okay? And see the gas mask? Not gas mask, regular mask. I don't know how good that is, but
跑步都跑不了，我天天跑步，灰尘特别大，他们那个什么烧火了，就放了烟一样。
That's on during the day. Yeah, come on. That's during the day, huh? Pretty nice, huh? You know, the U.S. Embassy in Beijing has air monitors, and they're making the Chinese government a little angry. I read about this because they would report the air pollution levels in the city, and so they have these monitors there, and the Chinese, the government's not too happy about that because they don't want the people to know how bad the situation is there, although they can just smell it and they know it's bad. So, anyway, I have here a chart about Beijing, and this is the app that I took from my phone 2 days ago, okay? You know, you can photograph it on your iPhone. This is what the app looks like. And not only does it have Beijing, but it has a lot of other cities on it, you see? And it gives you the color codes. So I find that interesting that here we have the daily readings in China from an app which is free. And of course, there is one for the whole world too you can get for free, or you pay about $1.99 or 99 cents. I forget what it is, but it's worth having. It shows you all over the world, including the U.S. You see this? So here on this day, I don't remember the day, it was just a few days ago, there's only one that had good quality. See, it's up to 42. Over here we have 125, which is orange, which is lightly polluted, okay? Again, this city, Hangzhou, is lightly polluted, and the rest are either good. But notice you have 6 cities, and you know, half of them, what do we have, 1, 2, well, actually 4 are okay, in the good range, and 2 are lightly polluted. Many times you would either see Beijing dark red or purple. You see it? And then this shows you where you get most of the emissions from, you know, pollution from surrounding areas, straw burning. Evidently they burn a lot of straw. Fugitive dust. You know what that is? Fugitive dust is when you have a car or tractor going over some land or some highway that's made out of dust, and you see the dust blowing up. That's what fugitive dust means. When a car runs over it, and you see that a lot too. Okay, now, here is another city we're familiar with, Mexico City, and because the air pollution is so bad, it might be called Mexico City. I think they want to change it, which sounds good. Let's see what this guy does. Coffee, he's having a tough time. So, anyway, now, this is a pretty bad situation. Mexico City, okay? And by the way, I got that name, Mexico City. That's what I got that from an environmental book. The guy was joking, but that's what it should be. I myself had the dubious distinction of living in Mexico City in 1968 for 5 months. And I'm telling you, you know you're in Mexico City 2 ways. You can breathe the air, which every day you can smell it, and then 2, I'll tell you an interesting story. I went out to Teotihuacan. Teotihuacan was the area where they have the pyramids from one of the Indian tribes many years, you know, a few hundred years ago. The Aztecs, or one of them, I forget which one. And so it's about 30 or some odd miles from the city. You can tell where Mexico City is. You don't need a compass, or you don't need the sun. All you have to do is look, and when you see, guess what? You see a whole plume of smoke. And a plume is a concentrated mass of pollution. So you would see it, and I never forgot that. I wish I had my camera. I didn't have a camera when I went on that trip. You can photograph that whole plume, and you know where Mexico City is. It was a big pile of smoke just coming from there. And you can see why. And this is a recent picture. So again, not much has been done. Now, I have here 2 movies on that too that I want to show you about Mexico City. I think you'll find them interesting. And, let's look at this one first. And then, Mexico has come up with a new invention, a building which actually cleans up the pollution on the outside. First, let's look at this one. This one's only 3 minutes.
Mexico City, Mexico. Population 19.5 million.
That's as big
It
as
is the
Australia,
10th
by the way.
largest populated city in
Australia
the
has
world.
19 million.
Like
Mexico
many other
City
large
is
cities across the world, it faces problems with pollution. Mexico City started rapidly industrializing in the 1960s. With this industrialization came a huge influx of population. Mexico City's population problem became evident as early as 1985. Various newspaper articles brought up this problem. Problems ranged from birds dying in large numbers to people suffering from lead, copper, and mercury poisoning due to the polluted air. Even during the winter, the school day had been pushed to start at 10 a.m. instead of 8 a.m. The government hoped that the extra 2 hours would allow smog in the air to clear away before children went outside. At the time, however, the government took little action, saying it was only a potential health problem. In most cities, pollution is able to escape since hot air rises and cold air sinks, allowing air to be circulated. However, the airborne particles of pollution do not have anywhere to go. To make the problem even worse, when the temperatures are low, a layer of cold air lies atop the pollutants, trapping them in the city. This is known as thermal inversion. Some of the main airborne pollutants include sulfur dioxide, nitrogen dioxide, carbon dioxide, as well as ozone, which is considered to be dangerous when at ground level. But there is yet another chemical that is also dangerous to the people living in the city. It is called PM10 of particulate matter. This particulate matter comes from anything from burning wood to laying in a new road, and it is more dangerous than ozone. While pollution problems were visible as early as 1986, Mexico City's problems persist today. What if you were a child growing up there? How healthy would you be? Health problems, particularly for the young and elderly, range from allergy-like effects to more serious illnesses such as asthma. However, not all hope is lost. The government has put programs in place that are believed to help remedy the city, such as ProAire and PICA. ProAire and the 3 programs that have followed since try to show the citizens of Mexico City more environmentally friendly ways to live than being generally aware of their surroundings. There are other initiatives as well, including educational programs in women's centers and schools. Communities are trying to learn what the pollution is about and how they can help. Although Mexico City has had a difficult fight with pollution for many years, there is hope for the future. While pollution cannot be rid of in its entirety, every little contribution helps.
Okay, now let's watch what they're doing about it. I find this to be interesting because can you imagine a building that actually cleans up pollution, not on the inside, but from the outside? Did I skip it? Is it this one? Oh, that's the one, yeah. You want to have it?
A striking building on the Mexico City skyline, this hospital tower also has a very unique feature. It eats smog.
This facade is coated in a special material, which, when hit by sunlight's UV rays, begins to break down pollutants. Designers say it neutralizes the effects of 1,000 cars every day.
Although pollution levels have declined, Mexico City is still grappling with being a megalopolis and the intrinsic problems it brings. There are some 4.5 million cars registered here, and that number grows by about 200,000 every year. The genesis of the design began some 10,000 kilometers away, in Berlin.
We were witnessing the rise of smart materials and their applicability in architecture. And what we saw was a city full of built structures that were essentially dormant.
Using a material called titanium dioxide, they developed a pigment that coats the tiles, or so-called modules. When pollutants come into contact with the modules, they're turned into compounds like water and carbon dioxide.
The design is inspired by natural shapes. It's kind of similar in appearance to corals. There is a need in the photocatalytic reaction for a maximum surface area. And the natural forms of corals, for example, is very good at doing that.
Mexico was the first country to commission the project as part of a $20 billion investment into health infrastructure. City environment officials are impressed.
What we have to do as government is develop the public policies that make these kind of bioclimatic designs obligatory and not voluntary.
For now, critics may ask what difference one building can make in a city of 23 million people.
We won't reduce significantly the levels of pollution for the entire city, but we can do it significantly for a localized area. where very high levels of pollution meets urban populations, so we're directly protecting people.
And this, say the architects, is a model that can be applied to any city around the world. Nick Parker, CNN, Mexico City.
Pretty neat, huh? Tell you, if we use our ingenuity right, we can do all this. All right. Now, let's continue. Let's see where I'm at. Okay. So, now, I want to point out something about Chicago.
If you're struggling with bipolar depression, there are treatment options. Ask your doctor if one's...
Now, okay, so I want to show you about Chicago, since that's where we are. And the air quality index of Chicago is as follows. Hey, what do you know, April 22nd, 307. What time is it now? It's 3:16. Hey, that was like 9 minutes ago. All right, is it 9? Is that like 307? Yeah, what is it, 307? Yeah, 9 minutes ago. All right, and this tells you the suburbs. See, guess what color it's in, folks? Well, what do you know? We're green. See it? Isn't that great? We're in the green zone. So look at that. See, same codes they tell you. So you can go on these, but anyway, I'm going to go into that in a few minutes. But notice how good we are at the present time. And of course, the critical pollutant is one of those criteria, ozone. See it? But we don't have much ozone, only 33. See it? Which tells you the ppm, or whatever units we use. So let's go back here. Now, let's continue with where we are. Oh, okay, now, remember in the movie they spoke to you about Mexico City and they mentioned something called the temperature inversion? Right. The temperature inversion is where you have something like a sandwich. Normally, a normal situation, you would have like this. You would have warm air, cool air, and cooler air in a normal situation. But when you have an inversion, what you have is you have warm air, cool air, warm air. Notice, this is a chart. This is the altitude. This is the temperature. This is rising temperature going up low. Notice, you go low, it goes down, then it goes up, then it goes down again. This is the warm inversion area. This area is warm. It's in between the two cold areas, and that actually traps the pollution down at the bottom here in the cold area. You see it? Cold, warm, cold. And we actually had an inversion here in Chicago a number of years ago. Get a load of this. It's a good thing I collect stuff like this. This was the newspaper from the Chicago Tribune, December 23rd, 1994. Get a load of that. How many years ago was that, right? Like 21, right? You see it? Okay? And we had here the carbon monoxide detectors went off. Why did they go off? Not because there was carbon monoxide produced by the houses themselves, but it was produced from the outside and it came in through the cracks, you know, doors and windows. Why did it come in? Because you had a lot of carbon monoxide outside and you didn't have the wind. You see it? You had an inversion because you had all those cars, and the cars were producing the carbon monoxide, and it would come in through the cracks in the doors and set off the alarms. So even here in Chicago area, we have these situations. This is not only a third world problem, okay? So I thought that was unique, and of course it was good that I kept the newspaper. You see, I have it forever. Pretty cool. All right. Now, let's look at Los Angeles, and then I'm going to show you a couple more things here, and we'll get to the good stuff. I have here, we know about Los Angeles, and they're in bad shape. We can get this up. Los Angeles Times. Forget it. Don't want this. So, no thanks. No thanks. Thank you. Now, subscribe. Of course. All right, I guess we're subscribed. Okay. All right, go buy whatever they want. I want air pollution. Huh?
Just an ant.
Rockin' Rio, the world's biggest music festival, is about to hit Las Vegas, and you don't want to miss. Get your tickets now.
Okay, your tickets, folks. Okay.
I'm Sarah Hashimoris in the Los Angeles Times newsroom. The American Lung Association says Los Angeles again topped a list of cities with the worst smog in the nation, violating federal health standards for ozone more than 122 days each year. The LA metro area and California's Central Valley dominate the latest annual air pollution rankings based on ozone levels, which contribute to smog as well as pollution made up of fine particles or soot. The Times reports that LA landed fourth among metro areas nationwide for short-term spikes in fine particle pollution, coming in behind Fresno, Visalia, and Bakersfield. Analysts found that the air was much cleaner in the latest period studied, 2010 through 2012, than it was decades ago, due to stricter emission standards for vehicles and coal-fired power plants. For more, visit LATimes.com and at LA Now on Twitter for the latest updates.
Thank you. Okay, we got that. Now, all right. So, now, why do we have a pollution problem? Okay? Okay. A number of things. I'm just going to give you a couple of them. Because everything depends on money, okay? Industry and stuff, they get their money from politicians. I mean, politicians get it. They give money to the politicians, and the politicians are supposed to regulate. But anyway, I don't have to go into more detail on that. You get the idea. Politicians like Joe Barton, who were bought by industry. I'm going to show you him in a minute. This is an incredible situation there. And then dumbing down by the media, okay? I want to show you a couple things. Now, I want to show you this picture. I show this to my classes. And this is really a prime example of why I get angry about why we're not doing things right. I'm sure everybody knows who the guy on the right is, right? Everybody knows who he is. But who is this guy on the left? I mean, well, on your left. Yeah, anybody know? Pete, you know? No one knows. Okay, he is actually my hero, and I'll tell you who he is. You see this hand? This is the hand that shook his hand. And what did this fellow do? Well, his name is Mario Molina. Does that ring a bell? No. What did he do? Well, in 1995, he and a fellow named Paul Cruzen and F. Sherwood Rowland won the Nobel Prize for chemistry. You know what they did? They figured out how ozone gets destroyed by the chlorofluorocarbons, okay? Yeah, nobody knows who he is. Everybody knows who Michael Jordan is. Why? Well, because he's a celebrity. At the time, he was bringing in money to Chicago by playing basketball, right? Okay, but who, if I were to ask this, who is actually more important for Chicago? The real answer is Mario Molina, because he helped save us all from getting skin cancer. You understand? Because he figured out how the ozone gets destroyed. And since they figured this out, they stopped using the fluorocarbons. They go to something else which does not have chlorine in it, okay? And by the way, the one that destroyed the ozone the most was something called CF12. That used to be found in the old car air conditioner. Now they use something called 134A, which does not have any chlorine in it, you see, and it still works. I have a car with an air conditioner, it works fine, you see, and I don't have to worry about destroying the ozone layer. So, this is part of the problem, folks. The media tells you what they want to tell you, and many of them are owned by corporations. Is that correct? Yes, they tell you what you should know and not know, okay? So this is why, and this is for everything, not only, you know, stuff like this. So I'm proud to say I met him once here in Chicago, and I had my picture taken, by the way, with him, and I was proud, although just my head was there. But anyway, so that's Mario Molina, and yes, he was born in Mexico. I think he works in Massachusetts now. So again, in 1995, he won the Nobel Prize. Recently, sometime this year, he won an award from President Obama, gave him an award for something he did, a humanitarian or something award. So the media is at fault, right? I'm sure you all agree there, right? I'm surprised. Nobody knew who this guy was. Well, now you know. So he's the real hero. You're all alive today thanks to him. But being alive is not as important as playing basketball. You got to realize that, right? Okay? I don't know how many spectators he'll get if they're all dead, you know. Anyway, now, I want to show you about this guy. This guy You know, okay. There is a representative from Texas, of all places, who loves oil. Now, what did I tell you at the very beginning of today's thrilling adventure in air pollution land? Remember, today is the 5th anniversary of the Gulf oil spill in the Gulf off of Louisiana. Well, the U.S. finally was able to get BP, which used to mean British Petroleum, but I call it bankrupt petroleum, a fine of $20 billion, okay? Which to me is still not enough. So I want to play, listen to what he said at one of the hearings. I lost it. Okay, let's go back. Hold on. I'm going to show you. I thought I had it. I guess I lost it. Let me just go back down again. You're going to be amazed. Where are we? All right, let me get this up. This is one of the most incredible things you've ever seen. Okay, here, he apologizes to BP.
I'm ashamed of what happened in the White House yesterday. I think it is a tragedy of the first proportion that a private corporation can be subjected to what I would characterize as a shakedown. In this case, a $20 billion shakedown, with the Attorney General of the United States, who is legitimately conducting a criminal investigation and has every right to do so to protect the interests of the American people, participating in what amounts to a $20 billion slush fund that's unprecedented in our nation's history, that's got no legal standing, and which sets, I think, a terrible precedent for the future. But I apologize. I do not want to live in a country where any time a citizen or a corporation does something that is legitimately wrong, is subject to some sort of political pressure that is, again, in my words, amounts to a shakedown. So I apologize.
That's Tom Hayward, CEO, BP. What do you make of that? Is that incredible? That's what I find. Okay, so what I've done, if he's in love with the oil companies, why doesn't he marry a barrel of oil? That's basically what he is, see? I asked his wife there. You know, these are the type of people you have. Can you imagine saying that? You know, he's apologizing for us for finding you guys guilty, you know? It's like apologizing to a murderer. I'm sorry we found you guilty. You know, same thing. So, anyway, all right. Now, what are the solutions? Number one, get rid of oil, coal, and gas as an energy fuel, okay? And this is the main cause. Go full throttle and going towards solar power to power 100% of the world's energy needs. And you'll see how we can do that. Elect politicians who really care about the environment, okay? A lot of them say they care, but of course they don't care, okay? Now, we all know what that is, the space station. Well, how does that work? Well, you all know how it works. They do not have a power plant up there, but they got one of the most powerful sources of energy in the whole solar system. They have the sun. You see it? And that's what we should use. Everybody here is a result of the sun anyway. You see it? Because you have food. Where does the food come from? The ground. And of course you have the sun to help photosynthesis. Okay? So here you have the space shuttle. Okay? Here we have the solar panels. So why shouldn't we have solar cars by now? We could have if we didn't waste our money, right? Yeah? Okay, now, let me tell you a story. This is an incredible story too. Indirectly, it's related to this. Why don't we have this stuff? Because our minds and our priorities are not here. Also, a lot of people don't think. Let me tell you what happened. This is a true story. 3 weeks ago, I went to a Dunkin' Donuts. And I asked the girl, I said, look, the clerk back there, I said, I want a coffee. I want 2/3 decaf, 1/3 regular with skim milk, and 1/3 of a teaspoon of sugar. So wait, I said, now, is that a hard thing to do? No, all they got to do is pour the coffee in, put a little sugar on the spoon and mix it. Okay, so I tasted, and it was very sweet. This actually happened. I said, you know, I think you put in too much sugar. All I asked for was 1/3 of a teaspoon of sugar. And you know what she said? She says, yeah, but the machine can only do 1 spoonful at a time. It can't do 1/3. So, you know, it got me to thinking, did they ever think of opening up the little packet and pouring it in the spoon and mixing it? See, this is where we've come to. Do you understand? That actually happened. And I said, my God, where are we heading for? You understand? We can go to the moon. We get this up there in space. We built it in space. Yet, one of these people who work in Dunkin' Donuts couldn't open up a packet, put 1/3, you know what I'm saying? Because the coffee was a little bitter without the sugar. I just want a little bit in. But you have to put a whole spoon in. You see the point? So this is, you know, something to be worried about. You know, they don't have the thought processes. You know, you might laugh at that, but it's true. Yeah, we can do all this. You've seen the pictures back from Mars. We're still getting them. It's tremendous. Anyway, so here we see some other solar panels, and we do have the technology. And so this is the way to go. And by the way, you can all buy them relatively inexpensive. A friend of mine who lives in Evanston, she put a panel for $300 in her house, and she put it up herself. She's a small lady from Thailand, and she actually runs her TV and the lights. And at night she can still run those because the battery gets charged during the day. You see, it comes with a battery that gets charged. I think it's amazing, so we can do that. Now, what I have done also, I've given you some web pages that I just want to mention real briefly about this. If you're concerned about the environment and the atmosphere and everything like this, I put a number of web pages on. I just want to show you a couple of these. Probably the best one is called 350.org. And what does the 350 mean? Well, the 350 means the maximum amount of carbon dioxide that should be in the environment. And now we've exceeded that. It's 400 now. So what I want to do is show you this. And this was put together by a fellow named Bill McKibben. So it's 350. Did I put 60?
Yeah.
It's not here, that's why. Yeah, 350, there it is. Okay. Go on there, it's 350, there it is. 350.org, okay? And this was put together by a fellow named Bill McKibben, who's a staunch environmentalist, and he's written some books on the environment. And it's a very good web page, okay? This is one that deals with the climate, okay? It's pretty good. And just look at that. It says the stats and the stories, 5 years since the BP oil spill, okay? This really was something that really woke up a lot of people, okay? And a lot of people are angry over it. And by the way, do not believe the reports that you see on TV where it says the Gulf is better now and all this. We just heard something 2 days ago in which they're talking about it. The fish are not coming back, not as in quantity. They're still sick organisms. You're getting blind shrimp. So don't believe what they say. They'll push anything. And then they show you pictures. Everyone's having a good time. The water is blue and all this. Don't believe everything you see there. Okay, then we have another web page. Go down here. Called Climate Hot Map. That was put out by the Union of Concerned Scientists, of which I'm a member, and gives you a lot of information on global warming effects around the world. It's pretty good. All these web pages, you can go online and look, you probably get hundreds of them. And then this one, the Spring Blossom, tells you all about air pollution. This one, by the way, is my web page. I'll show you that one. It has a lot of information. I'll show you where to go to get it. It's called davids-earth.org, and I have a whole bunch of stuff I have about my books, the videos. You'll see me on videos, resumes, students deal with my schools. And over here on the left, or down here, I have a whole bunch of links. You see them? All these are links. They used to be on the left. Anyway, regarding environmental stuff, okay? I have a whole bunch of stuff there, including a comedy show if you want to watch it someday. Anyway, I have a lot of stuff that I show my class, and it's all environmental. Well, most of it is anyway, about the ocean. Here we have 350.org, the fungus page, crustaceans, a whole bunch of stuff. Oh, there is one other one I want to show you. It's called cleantheair.org. All you got to do is click on it. Click on those and you get these web pages. This is actually another web page which tells you about the air in Illinois. You see it? And notice this, April 22nd, which is today, tomorrow, and the next day. It's all pretty good. See it? So we're in pretty good shape, Illinois. And that's because of the laws we have at EPA. So at least we're pretty good at practicing that. And this shows you a whole bunch of stuff, okay? This is probably a very good one. Okay? It tells you air quality. You have a whole bunch of stuff. See, it goes into some of the stuff I mentioned today. Air pollution action days, good ozone versus bad ozone. I mentioned that briefly. And particulate matter, that's the relatively new term these days. So there's tons of stuff up there. And anyway, so with that, does anybody have any questions, comments, anything? No? Okay, well, oh yes, you have one. Go ahead. Thank you. Yeah.
This building in Mexico City that needs to come on.
Yeah.
I didn't get when they put that up, but
I don't know.
Any other cities doing that?
That's a good question. I don't know. I didn't investigate. They probably are, but I just don't know. That's a good question.
Because I didn't know if they were like measuring the effectiveness, because the lady talked about she'd like to like make it mandatory, and I was just wondering if it's working, you know, why others are.
Yeah, I wish I knew. Yeah, I guess we'd have to look up that information. I have no idea. I would assume, because if they did it, other people are going to start following in their footsteps. That's what I assume, but like I say, I have no facts to back me up, as an ex-presidential candidate used to say. That was a good question. I wish I knew the answer, but now I'll investigate it. By the way, Mexico City, as I mentioned earlier, they have about almost 20 million people, which is the population of the whole continent of Australia. And of course, most of Australia is on the coast, because most of it's desert in the middle called the outback. Not to be confused with the restaurants out here, that's a different outback. Although I think it's Australia. Anything else? Questions, comments? Yes, sir, Bruce.
There's a commercial that's on TV talking about voting to keep the nuclear.
To keep them or to get rid of them?
To keep them.
Oh, right. I think I got a message on that. Yeah.
Yeah.
We
So
don't want.
what do you think? Do you think does that help the pollution? Or
No, absolutely not. It's more dangerous. I'll give you two words: Fukushima and Chernobyl. That should scare the hell out of anybody. Yeah, absolutely not. We got to get rid of nuclear. Let me tell you something about nuclear. Did you ever hear of the Shoreham nuclear power plant? No one ever heard of it, right? This is one of the most incredible stories ever. I'll just show you a picture of that. I'm glad you mentioned that. I'm going to show you this. The Shoreham nuclear power plant was built in Long Island in the 70s. And it was about 300 miles from New York City. And they built it. But they realized a number of issues came up. They didn't have a New York City evacuation plan. So guess what? Some other things came up when I think it wasn't Pataki, it was Cuomo was governor. And what happened was they decommissioned it. They never generated any electricity for anybody, okay? So it's one of the strangest tales ever. This is the Shoreham nuclear power plant, never generated electricity. They spent $5 billion with a B building it and $500 million decommissioning it. So, which was good. You know, we didn't need another nuclear power plant. But anyway, so I hope I answered your question. Definitely not. I am 100% against nuclear. Look at the one accident in Japan. Guess what? California's getting some of the radiation. Even though a lot of it was diluted, they're still getting it. See, so, by the way, if they want you to vote no on nuclear. Absolutely not. Unfortunately, Illinois has the most nuclear power plants of any state. We have 11 of them, or nuclear reactors. We have 11, okay? You know how many there are in the U.S.? 109. The world, there are 424 nuclear reactors. France has the most. France, by the way, gets 73% of its electricity from its 59 nuclear reactors. They have 59 of them. But of course, fortunately, they know what they're doing. We do not want another Chernobyl. We already had two big ones. 3 Mile Island was not as big as Chernobyl, and Fukushima's still creating havoc, you know, still leaking after a couple of years. But I'm glad you asked that. So as far as I'm concerned, 0% nuclear, we got to get away 100% of fossil fuels and just go solar. Because look, we're all a result of solar anyway, right? If the sun goes, we all go. So, but you saw the space shuttle? That works fine on solar power. You are all eating, right? Well, why do you eat? Because of solar power. Everybody here is a result of solar power, right? You're all literally, as Tom Hartman said, a result of ancient sunlight. Because he wrote a book about that called The Last Hours of Ancient Sunlight. You know that book? Yeah, he has a radio show. In fact, he's on right now. No, he used to be on till 2 o'clock, from 11 till 2 on WCPT. 92.7. Yeah, very good show. He's a genius, that guy. Any other questions? Yeah. No, don't worry about that, Danielle. Go ahead.
No, is it like people working in the solar system?
What do you mean?
Like, when you showed the picture, like...
The space?
Yeah.
Space, yeah. People were up there, about 5 or 6 of them. They live there. Yeah. In fact, since you asked that, let me show you. It's funny you mentioned that because the other day I went online. Watch. Let me show you this. It's hard to see here. The computer's way down there. Google screen. Watch. Space station. You can see they can watch a video of it, and the guy gives you a whole tour of it. Space station tour. See? Gives it to you right up there. See? He's right there now. See? Gives you a whole tour of it. See it? Pretty cool.
And so you need all these things to keep your stuff in place, because otherwise you lose it. It just floats away.
There are about 5 people there, so you can watch it. Isn't that cool? You can get anything on the internet. You see how quick it is? Now, since he asked me that, since this is Danielle, she asked me this question. Here we have all this wonderful technology, right? You want something, we find it immediately. That shows you we can use our ingenuity. So why don't we use it for energy so we don't have to keep polluting? You see it? Now, true, it took electricity to run this, right? Wouldn't it be better if this electricity runs from the sun? And by the way, I have a number of students here from, I teach at Crystal Lake, Columbia College of Missouri up in Crystal Lake. I also teach at Columbia College. They have 35 extensions in the U.S. I also teach at Gurnee. In the buildings we're teaching at, guess what? They're only 1-story buildings, right? So, what's wrong with that 1-story building? Neither of them have any skylights, where the architects could have put in skylights so you wouldn't have to use electricity. You see, and now when I teach during the day, we use the light from the windows, especially in Gurnee, because I teach Saturday mornings. We have big windows. The whole wall is windows. But why couldn't the building designers put skylights? Because we have other classrooms that don't have any windows, you see? They didn't use their brains. Now, I lived in Israel for a number of years, and if you look at the factories in Israel, most of the factories have skylights, because they run during the day, right? So why not use the solar energy? You see it? So we have the ingenuity to do it, we just don't do it. Because of, like I said before, you have these politicians, you have money and all these other things which are clouding our thought processes. And the media does not help, believe me, right? And I'm sorry to tell you that, but I'm sure you can figure that out. The media, I hate to use this term, but they are kind of dumbing you down because they're not telling you what you should know. You agree?
Yeah.
Good. Anything else? Oh, yes, go ahead.
I have a question. You showed the building in Mexico.
Yeah.
That was able to clean up the air
right.
from the outside. And with all the pollution mostly being concentrated in Asia,
yeah.
I'm just wondering if you are aware of any buildings of that kind in Asia, in those
Yeah, it's a good question. No, I don't know. I never even thought about it. And notice that they need it. Now, let me tell you something about Asia. If you've been reading the papers, the Chinese themselves are complaining about the air pollution. But the government is slow for 2 reasons. First of all, they're still not 100% out of the communism box, so to speak, and they have too many people, see? But I should say this, on behalf of China, they are developing a lot of green energy sources. I think they're big on wind and solar power. It's just going to take them a long time. See, one of the reasons for that pollution, I should say, is in the middle of winter, and it's very cold there. Why the middle of winter? Because in the wintertime, they have to keep warm. How do most homes keep warm in China? They burn coal, you see? That's why you have so much air pollution. It's coal burning, okay? So it's mainly during the winter. Now, I doubt. See, normally, now, for the last few weeks, I noticed when I go on the app, the Chinese, at least it's in the orange or less range. It's no longer red. And that's probably because of the season. The winter is over and it's warmer, so they don't use coal. There's less pollution. But they should do that. And we saw that map of Asia, right? Almost all of it's red or purple, right? Which is terrible. Almost all the whole U.S. is green or yellow, right? Which I think is amazing. Were you here, Michael? Did you see that map? Yeah. So that's tremendous. Isn't that a great map? So you can get anything you want off the internet when you want it. So I think it's perfect. Now you know what the space station is. There's about 5 or 6 people living there. By the way, there's very little space. This picture looks kind of big, but you don't know how big it is. You know, they're very small there.
Can people go up there and travel, like take the tour?
Maybe if you have money, I think you can go there for $20 million. Isn't that it?
Yeah.
You got to have 20 million. A few people have done that. You got 20 million to spare, they'll be glad to have you. It's true. I think that's what it costs. Yeah, it's not like an airplane ticket. Any other questions, comments, anything? Yes, sir.
About 50 years ago, we used to, as a teacher, I was also in the summertime working as a janitor, and we used to burn everything in these apartment buildings.
Yes, I remember.
Larger apartment buildings.
Yeah.
I mean, we burned all the garbage.
Right.
And including paper, books. The only thing we were concerned about was the aerosol cans.
Right.
That they would blow.
Yeah.
But other than that, we did it all. But I guess nobody was concerned at the time.
No, because you see, they weren't concerned about smoking either. You see? And the thing that got me, I'm glad you mentioned that. Now they fill up the landfills with the garbage because they know it's bad. One thing about smoking too, I want to mention. When I would go on airplanes, the captain would make it a point. Okay, guys, the smoking light is off. You can go smoke. That really burned me up. Worse than the cigarettes. Yeah, you make a good point. See, they didn't know about cigarettes. They didn't care. Cigarettes, in fact, lucky strike. Even doctors smoked. Everybody smoked.
They did.
Yeah. And you make a good point. Well, as we advance, we realize we made some mistakes. I'm glad you said that. Now the landfills, trouble with that is they're getting filled up. Too. They're running out of landfill space. They say only 11, 12 years, so I don't know. It's a big problem. We got to produce less. And by the way, the rich countries suffer from a disease called affluenza. And by the way, there's a good definition of environmental pollution. It's the effluence of affluence. Isn't that great? Which means the garbage of the rich. If you're rich, you produce more garbage. By the way, one thing before we end. I should say that the garbage business is a good line to get into. Why? Because business is always picking up. Okay, with that, folks, thank you for coming. Thank you.